Hello. Right, in this video, I'm going to show you how to calculate the x in this formula. The x is just the number of moles of water to the number of moles of the anhydrous sodium carbonate. Anhydrous just means it hasn't got water in it, but here it has got water in it. And we've got three masses here. We've got the mass of an empty basin. Then they put some of the solid in, which we don't know the formula of, that contains water, heated it up, and then weighed it again. So we basically got three weighings. It might be useful to number them. Now, the first mass that we can calculate, let's start over here. The mass of the hydrated salt, which is this. We don't know how many moles of water there are, but we can start somewhere. So if we do the mass of the evaporating basin of the basin and solid, minus just the basin. So we want 25.47 minus 24.35. And that is 1.12 grams of the hydrated salt. What we can't do is find out what the moles of the hydrated salt is, because we don't know what X is. So let's leave that for now. We've got the mass of the hydrated salt. Now we can find the mass of the water simply by using another two figures. You can probably work out which two we need. We need the one before heating and the one after heating. So obviously the one after heating has lost some weight. So you need to do that figure minus that figure. So that becomes 25.47 minus 24.92. I'm just going to, if you want to put that into your calculator as well and check whatever I'm doing, because I'm not really good at calculators. I prefer doing mental arithmetic. But here we go, 25.47 minus 24.92 is 0.55. And that's, of course, grams. The next thing we want is the mass of the anhydrous salt. This is sodium carbonate with no waters on it. They've been removed by heating. So we could do that by, there's various ways you could do it actually. You could just do that one minus that one. No, we've done that one, that's the water. So if we do that one, if we do 3 minus 1, that will give us the mass of the hydrated salt, won't it? Unhydrated salt, right. So 24.92 minus 24.35. In a minute. 24.35. Once again, if you can put that into a calculator, there's nothing wrong with practicing using a calculator. 24.92 minus 24.35. That gives you 0.57 grams. 0.57 grams of the anhydrous salt. Now, the two figures that are important now are this one. Well, we've already used that, haven't we? So let's see. We need the mass of the water and we need the mass of the hydrated salt. So we need that one. We need that one. Not quite sure why I bothered with that one, but It won't do any harm. It's good practice. Anyway, what do we need to do? We want to find out the moles of the water, not the mass. Well, that's easy. N equals M over MR. So for water, N equals 0.55 over 18, which is the formula mass of water. And again, I will resort to the calculator for this. So 0.55 divided by 18. According to this, that is 9.9 moles. That can't possibly be right, can it? 0.55 divided by 18. Is 0.306. 0.0306. Okay, sorry about that. Now, that's the moles of water. Now, we can also find the moles of sodium carbonate now, because we've got a mass for that, but we need to add up the formula mass of sodium carbonate briefly. So we're going to have to do that maybe over here. So Na2CO3, we've got two sodiums. Sodium is 23, carbon 12, 316s, oxygen 18.
Right, well, it should be 46 for two sodiums.
That adds up to 106.
And 316s is 48.
So if we put,
but it does indeed add up to 106. He's being silly.
Over 106.
106, well done.
N equals MR, M over MR. Again, is this time 0.57 over 106. So once again, we can do that calculation. I don't really like combining decimals and real numbers, but never mind. 0.57 divided by 106, in fact, is 0.0054. Okay. Let's put these numbers in some sense then. So the 0.0054 is the moles of sodium carbonate, and the 0.0306, the bigger number, is the moles of the water. Now, if we dissolve one by the other, then we should get the value for X. So let's do that then. So, hang on. So it's 0.0306 divided by the other one, the smaller one, 0.0054. I get 5.67. Well, really, X should be an integer. So that means one of two things. Either I've done something wrong, or maybe the experiment isn't very good. Now, that is something to consider perhaps for the next video. So just have a think about how perhaps that experiment might have been improved in order to get an integer. X should be an integer. You can have fractions in a chemical equation, but we don't put fractions in chemical formulae. Thank goodness. Let's not start doing that, because that would be so confusing. Okay, thank you for watching this. If it was any use whatsoever, please leave a like. If you don't like it, then please don't watch anymore. I mean, there isn't a lot of point, is there? They're all the same. Okay then, see you in the next video, hopefully.